This is a challenging probability question, so I'm going to deal with it using a Venn diagram because there's trains and cars, and then there's kind of people not using trains and cars, and we could use a two-way table, but it just feels like a Venn diagram is a good approach. So if I draw my Venn diagram, then the left-hand circle might be the people who use a train, and the right-hand people who use a car. Now I'm told that 7 did not use either, so I can write 7 outside here. I've got 21 people in total. I've got 12 that used a train, but that's all of this. So how does that help? Well, I know there's 21 people in total. I know that this is 12 here. So 12 plus 7 is 19, and it must be that this is 2. Because I've basically done 21 minus 12 minus 7 to get that number there. It's the bit that's left over after I've taken up this space with 12 and this space with 7. And then it's all gonna come out, because this has got to be 4 to get this up to 6, and then this has got to be 8 to get my my 12 for the train. And yeah, I've used everything there. Okay, that bit's not the hard bit actually. The hard bit is the next bit. 2 people are chosen at random from those who used a train. Okay, so this is actually in some sense, well, no, not in some sense, it is a conditional probability question. We're told that people are chosen at random, but this is extra condition that they used a train. So I'm just gonna basically cross these people off because they didn't use the train. I'm only asking these 12 people here, or sorry, choosing from these 12 people here. So find the probability that both these people also used a car. Right, that's the tricky bit, because normally it's like just find the probability that one person did it, in which case it would be 4/12, but we've got to consider a second person as well. So actually I think the best approach, I'm going to go through it slowly, is to use a tree diagram. So it could be we know they all picked the train, so then they either picked the car or not the car. And the probability that they also used a car, that would be my 4/12. I'm not actually interested in the not car bit. Where I'm going with this is that the second pick, right, that's another person picking a car, but I've picked somebody. This is the thing, this is like a probability now without replacement. So I've picked that person along the tree diagram. So how many are left? There'd only be actually I'm going to even cross this out and change it to a 3. Like, I've picked that person along the tree diagram now, so there'd be 3 people left that also used a car, and there'd be 11 in total. And my ultimate probability is going to be 4/12. So my pen has decided to stop working. 4/12 times 3/11. And I can multiply this out. Actually, how is this? I can't remember if this is a non-calculator question. So probably the best approach is to simplify this down. This 4/12 is actually just 1/3. So it's 1/3 times 3/11. And then I can either multiply the tops and the bottoms to get 3/33, which cancels down to 1/11, or I can sort of actually just cancel them out using my knowledge of multiplying fractions. The answer is 1/11. So this is a tricky question because you first of all have to find an approach to get the information in order. Two-way table, Venn diagram, frequency tree. I've opted for a Venn diagram here, but then I'm using this conditional probability. But then I've got to think about the fact that I'm doing it twice. It's without replacements. I've got to basically multiply the 2 probabilities. You don't actually need the tree diagram. If you become confident with tree diagrams, you can just recognize that it's just going to be the 2 probabilities multiplied together. I don't worry about any of this, but I wanted to illustrate it using a tree diagram to make it clear, which I hope I did.